Hello, welcome. So this will be binary of a binary tree, question 453 on Leetcode. And as you can see, we are given the root of a binary tree and we have to return the length of a diameter tree. So the root obviously is going to be this one. And the diameter of the binary tree is the length of the longest path between any two nodes in a tree. This path may or may not pass through the root. So we can see that the diameter will be the longest point between two nodes. So it can be here and here, or here and here, or here and here, right? It doesn't necessarily have to be the height. So like 1, 2, right? So right here we have to find the length of a path between two nodes. Okay, the length of a path between two nodes is represented by the number of edges between them. So we are looking for these edges right here. And as we can see, the output is 3. Why is that? Because if we go through path, like it says 4, 2, 1, 3, 4, 2, 1, 3, then we count 1, 2, and 3. Or we can also go 5, 2, 1, 3. So there are 3 of these lines, and that gives us our length. So this is going to be another problem that we have, and in order to find the solution of this, we are going to look for the diameter, which was defined as the longest point between two nodes. So if we look over here, what is the diameter starting at 1? We see that we have on this side 1, 2, 3 from the right, and then we have 0 from the left. Therefore, our height will be 3 plus 0, which equals 3. So the diameter, the definition of this, we can also say it as the height of the left from the height of the right of each of these points. So we can do this recursively. And as we go recursively, we can find the diameter for each of these nodes. So if we go to 2, we see that 1, 2, 1, 2. So 2 plus 2 plus 2 plus 2 equals 4. Therefore, the diameter of this will be 4. We can also do this in different combinations. We can have it go right here and then right here, which is also 2 plus 2. And we see that right there it's also 4. So there are different possible ways to obtain this diameter, but that's just what we have to find. So in order to achieve this, we have to keep track of the diameter, and we also have to keep a track of the height. So I'll show you the algorithm for this, the solution, and this is a solution. So we're going to start right here in the top, and our diameter, sorry about that, our diameter is going to start at 0, and that is the global variable that we're going to track our diameter with. So if we do that, then we can define a definition of depth first search. And if we define depth first search, then we can see that we're going into this non-local res, which that just defines res globally. That just helps us have it globally. Another way would be to do self.res for each of these spots. So right here, and we'll be able to access it globally. Another way was how I have it here. So now we're going to go to if not root. So what does if not root mean? It means that if the root is null, then we return 0. So that is going to be our base case for this recursive function. And as we can see that right here, we are not going into null. Null would be just an empty spot like that. And since we do have we're going into 1, we will skip over that and we will go to the next section, which is this line right here. So we can see depth left equals depth first search, our function, and then root dot left. So if we go to the left, what are we going to find? We're going to find we're going to find null on our left. And if we go to the right, we're going to find node number 2. Therefore we can follow this one. We're going to follow the left and see where that takes us. So if we follow the left, we're going to go into the null. So let's follow along with this. And null will go into if not root and then return 0. If we return 0, then our left will be null. And now moving on to the right, our right is 2. So if we follow the right, we're going to be at this node. And so let's go. So we skip this section right here, and we're going to end up in left equals DFS root dot left. So again, let's go see what is to the left of 2, and to the left of 2 is going to be 3. If we follow that, what is going to be to the left of 3? It's going to be 5. So if we follow to the left of 5, what is to the left of 5 if not null? So we can see that right here, it is going to be null. So left is going to equal null. And if left equals null, we could also do the other side. What does the right equal? It is going to be null. So we're going to write null for this section. And moving on to this portion, we're going to see that we want to have the max of the, we're going to add the left and right as we talked previously and compare it to res. And if we compare those, we're going to grab the max, and our max will be 0. And we're going to return 1 to the previous one. So if we return 1, since right here we'll have a height at 1 at this level, then we will at that level, then we are going to be able to define left as 1. So now moving on to this section right here, null is, as we know, 0, so gonna have a height of 0, therefore we write 0 at this section. And if we go to the right, and if we have our put our right and our left in the correct spot right here, then we can see that res is going to add up to 1. So after it adds up to 1, then we are going to add that to the other one, and we're going to return 2. So let's return 2 to the previous one. And now, as we know that the left is going to be the left node, which is number 3, is going to return a height of 2, so 1, 2. And as we can infer that this section will also return a height of 2, because it is going to be 1, 2 right there as well. So for node 4, we're going to return 2, And if we add the left and the right, then we can see that compared to 0, it's going to come out to 4 because 4 is greater than 0. So now we can see that our current, the highest res that is going to be saved is 4. And if we return the right and the left height, we have to add 2 plus 1, and we get 3. So now if we return over here, we can see that all that work got us the height of 3. So if we go to 2, we can check that that is true. 1, 2, 3. That is the correct height. Therefore, what that is going to allow us to do is to now compare the right here and compare the left, which was null. And we are going to be able to add it to 1. So 1 plus 3 is going to equal to 4. So we have a height of 4 right here. And all that was getting this answer of 4 was extra work, because we already know that the max res was 4 from the other iteration. And if we compare right here, we get null plus null, which we know that 4 is going to be higher than null plus null. Therefore, res 4 is going to be our final answer.